Welcome to STEM AI Robotics. You don't need experience, just curiosity. In this course, you'll build, code, test, fix, and improve real projects using electronics, AI, and robotics. By the end, you'll begin thinking like a robotics engineer. Before we build, let's map the journey. You'll start with ESP32 basics, then add sensors, motion, IoT control, Arduino robotics, Raspberry Pi vision, and finally bring everything together in a showcase project. The goal is steady growth, from beginner skills to confident intermediate builds. Think of this course like a staircase. We begin with what robots are, then give them a brain with ESP32. Next, we add sensors, motors, movement, and wireless control. Later, we compare platforms and connect robotics to AI and vision. Each project follows the same cycle: understand, build, test, debug, improve, and explain. Use this course in the way that fits your starting point. If you are new, begin at Lesson 1 and move step by step, because the early builds create your foundation. If you already know some electronics or coding, you can move faster, but do not skip setup or safety. If you are advanced, treat each lesson as a reference, then customize. The best habit is active building. Keep notes, test one change at a time, and when you get stuck, describe what you built, expected, observed, and tried. Now we begin with the core idea behind every robot. It is a system. A robot gathers information through sensors, processes that information with code, then responds through outputs like lights, sounds, motors, or movement. The ESP32 will become the brain of our beginner robots. Nothing here is magic. When we understand the parts and their jobs, we can build, test, and improve real machines. So what makes something a robot? The key idea is not whether it looks human. A robot is a machine that follows instructions to do a task, and often combines three abilities: sensing, thinking, and acting. A traffic light or washing machine may be automated, but it usually follows a fixed pattern. A robot car, arm, drone, or rover can use inputs, process them, and change what it does. When you are deciding, ask, does it take in information, make a decision, and produce an action? A useful way to understand robots is as a loop: input, process, output. Input is the information the robot receives, such as light, distance, temperature, a button press, or a camera image. Processing happens in the code running on the robot's brain. It checks conditions and makes decisions. If it is dark, turn on a light. If something is close, stop. Output is the action that follows, like spinning a motor, moving a servo, sounding a buzzer, or displaying data. Robots need inputs before they can make useful decisions. A sensor is like a robot's sense organ, measuring something from the world. A camera or light sensor detects what can be seen. A sound sensor listens for noise. An ultrasonic sensor measures distance, like an invisible measuring tape. Buttons and keypads let people give commands. Temperature, humidity, and motion sensors report conditions around the robot. Sensors provide data. The program decides what that data means and what should happen next. Once sensor data arrives, the code gives the robot decision rules. A simple rule might be: if the light level is low, turn the LED on. Otherwise, turn it off. That same pattern works for many behaviors. If something is close, beep faster. If a button is pressed, open a gate. Robots repeat this cycle constantly. Sense, decide, act, then sense again. Clear, organized, testable code makes it easier to check, fix, and improve the robot. Outputs are how a robot turns a decision into something we can see, hear, or feel. An LED can show status. A buzzer can warn. Motors and servos create movement. Displays show information, and relays or pumps control bigger devices. For example, if a sensor detects a nearby object, the ESP32 can respond by beeping a buzzer and turning on a red light. Every robot is a meeting place for STEM. Science helps it understand the physical world: light, sound, motion, force, electricity, and energy. Technology provides the tools to sense, compute, communicate, and store information, from sensors to microcontrollers and wireless links. Engineering turns ideas into working machines through structure, wiring, power, testing, and reliability. Math helps the robot measure distance, calculate speed, compare values, time actions, and choose based on patterns or thresholds. When you build a robot, you are not studying STEM separately. You are using all four together. You can spot the input, process, output pattern in everyday technology. A parking sensor takes in distance, checks whether something is close, then warns you. A drone reads sensors and GPS, processes balance and direction, then adjusts its motors. A home assistant turns your voice into a command and responds. A factory arm follows instructions, checks its position, and moves or grips. Different machines, same basic idea. Sense, decide, act. Before you power anything, pause like an engineer. Check every wire, especially power and ground, and make sure nothing can short. If you are unsure, stop and ask before connecting USB or batteries. Keep liquids away, keep small parts organized, and never force components into a breadboard. Unplug power before changing wires. Treat motors, wheels, and gears with respect, because they can spin suddenly. Use the correct battery voltage, avoid damaged batteries, and keep metal away from terminals. Safety is not extra work. It is good engineering. Real robotics is not about getting everything perfect on the first try. It is about working through a cycle. First, ask what the robot should do. Then plan the sensors, outputs, and controller. Build the connections carefully, write the code, and test what actually happens. When something goes wrong, debug it. A mistake is information, not failure. Improve the design, then explain how it works so someone else can understand your choices. Every project in this course will use this same engineering mindset. Great work! You now know that a robot is a system that senses, processes, and acts. You've seen how input, process, and output connect robot behaviors, how STEM works together inside these machines, and why safe building habits matter from the start. Next, you'll meet the ESP32, your first robot brain, and learn when to use it.